Hello everyone, I think you all are fine and concentrating on your studies. Dear students, many times I told you that this is very important period for you to prepare for your competitive examination as well as your class 12th preparation. So concentrate more and utilize this time to the fullest. Dear students, this is a new video related to differentiability and the topic is parametric functions. While studying this topic, we are going to keep two things in our mind. The first thing is what are parametric functions, and the second thing is how to solve the differentiability of parametric functions. So these two things we are going to study in this video. So let's start. First of all, let's start with the concept of parametric functions. What is the meaning of parametric function? See, actually we have studied the cases like y equals to fx. When y is expressed in terms of x, such kind of differentiability we have already done in class 11th also and in elementary level also, okay, in class 11th. So y equals to fx, that you are familiar with. We have also studied the function which are of the form fx power gx. It means you can see that y is expressed in terms of x. For example, y equals to x square plus 1. So it means there is a direct relationship between y and x. Y is expressed in terms of x. So such kind of function, it's very easy to find out the differentiation with respect to x. So if we want to do that, dy upon dx equals to d over dx of x square plus 1, that will be 2x. So it's very easy if you know the formula. Here the problem is that this is parametric form. And what is parametric form? When x and y are not directly related. This is very important. Then in parametric form they are not directly related. So what is happening? Means x is expressed in some other variable t in place of y, and y is also expressed in some other variable t, not in terms of x. And our aim is to find out dy upon dx. So in such kind of things, what is happening, that x is having a relationship with t and y is also having a relationship with t. It means both are having the relationship with t, but they are not directly related. So you can see that x is having a relationship with t and y is also having a relationship with t. So it means they are indirectly related because both are in relationship with t. So it means there is some relationship between them also. So you can say they are not directly related, but they are indirectly related. So when such kind of situation is there, then we say the equations are in parametric form. Okay, so this t, that is the base, so it is called the parameter. This is called the parameter, and this x and y both are called the parametric functions. Okay, so it means x and y both are not directly related. They are expressed in some other variable, that is t, and that t is called the parameter. That's why we call x and y as parametric functions. Is it clear to you? Now you see the definition. What are parametric functions? A relation expressed between two variables x and y in the form x equals to ft and y equals to gt is said to be parametric form, where t is called parameter with t as parameter. So this is what the definition, but you should understand the concept that I already discussed with you. Okay, now you see with the help of an example that how to do that, how to find out the differentiability. So I have taken one of the case, that find dy upon dx if x is expressed as ft and y is expressed as gt. If you want to solve it, then if x is ft, obviously we can solve something that is differentiation with respect to t, that is d over dx of ft. That is very easy to find out. That is very easy question for us. If y is expressed in gt, then also it's very easy. dy upon dt we can find out, and that will be d over dt of gt. So what is happening, that we can find out dy upon dt and we can find out dx upon dt. But the question is find the differentiation with respect to x, not with respect to t. So in this case, how we are going to solve? We are going to use both these values and we are going to divide this value by this value. So dy upon dt upon dx upon dt, dt will be cancelled. So we will get dy upon dx. So this is what written here. So you can see it here. Dy upon dx is dy upon dt upon dx upon dt, where dx upon dt should not be equivalent to 0. So very easy to solve. What are you going to do? First of all, you should know that this is the parametric form. If somebody asks you, you should be familiar. And how to solve it? This is simple method. First of all, you find out the dx over dt, then you find out dy over dt, and then you divide dy over dt by dx over dt, and you will get your answer. This is the simplest approach to solve such kind of question. Okay, now you see one of the example. Find dy upon dx when x is sin t and y is cos 2t. So obviously clearly this is parametric form. So how to solve it? First of all, you take this x equals to sin t and find out the differentiation with respect to t. So dx upon dt, d over dt of sin t. So sin t, the formula is d over dt of sin t is cos t. So we will get dx upon dt equals to cos t. Now the second function is y equals to cos 2t. So dy over dt is d over dt of cos 2t, and cos 2t, you know very well, we have to apply the chain rule here because cos 2t is not the standard function. Cos 2t is not the standard function. The standard function is cos t. We are differentiating with respect to t, so there is no problem. The function is cos t and we are differentiating with respect to t. But in place of t, what is here? 2t. So how are we going to solve it? Just see, d over dt of cos 2t. So first of all, you just imagine that it is simple cos t, standard function. So what is the differentiation of cos t? That is minus of sin t. So you are going to write minus of sin t. But in place of t, you are going to write 2t because what is here? 2t. Okay. Now as you know that we have imagined t, but actually the real value is 2t. So we are redifferentiating it. Whatever we imagine, we redifferentiate it according to the chain rule. So d over dt of 2t. So d over dt of 2t is nothing but 2. So our answer will be minus 2 sin 2t. This is what our answer will be. So minus 2 sin 2t. So this is what we are going to get. Now what is left? Simply divide this expression by this expression and you will get your answer. So just see. Now dy upon dx is, you just divide. So minus 2 sin 2t upon cos t, and sin 2t, you know very well, this is 2 sin t cos t. This formula is very easy for you and everyone knows it. So this will be 2 into 2 sin t cos t upon cos t. Cos t and cos t will be cancelled. So what will you get? Minus of 4 sin t. This is what you are going to solve. Very easy questions. Nothing is tough. Only you should be familiar with the meaning as well as the method. Okay. So dear students, I'll discuss some more question related to parametric equations, and it's a very important topic and it comes in the competitive examination also. So I would like to ask you or request you to share, comment as well as like this video, and you can post your doubts to me. So thank you so very much.